Hello, in this video I'm going to talk about the laws of indices, also called the laws of exponents, as shown here in the syllabus. In expressions like a to the power of k, an a is called the base, and k, the power, is also called the exponent or the index. And if the exponent k is a positive integer, and by that I mean a positive whole number, it determines how many times the base a is multiplied by itself. So for example, 10 to the power of 6 means multiply 10 by itself 6 times. 3 to the power of 4 means multiply 3 by itself 4 times. If the exponent is a negative integer, it determines how many times to divide 1 by the base a. For example, 10 to the power of negative 3 means to divide 1 by the base 10 3 times. That's equal to 1,000th. 4 to the power of negative 2 means to divide 1 by the base 4 2 times, and that's equal to 1/16. Alternatively, you can think of it as how many times 1 over the base a is multiplied by itself. 10 to the power of negative 3 means multiply by 1 over 10 3 times. That's equal to 1,000th. 4 to the power of negative 2 means multiply by 1 over 4 twice, and that's equal to 1/16. The laws of indices, or exponents, are a set of rules that you need to be familiar with. The first one states that if you multiply numbers with the same base, then you add the powers. For example, x to the power of 5 multiplied by x to the power of 2, you add the powers giving x to the power of 7. And performing that calculation numerically, 4 to the power of 5 multiplied by 4 to the power of 2, you keep the base the same and you add the powers, giving 4 to the power of 7. We can verify this on the calculator. Select the matrix and type in 4 to the power of 5 multiplied by 4 to the power of 2, and similarly to type in 4 to the power of 7. And we see the results are the same. The next law says that if we divide numbers with the same base, then we subtract the powers, keeping the base the same. For example, x to the power of 7 divided by x squared, we subtract the powers giving x to the power of 5. Or numerically, 3 to the power of 7 divided by 3 squared, we keep the base the same and we subtract the powers, subtracting 2 from 7, giving 3 to the power of 5. Checking this on the calculator, 3 to the power of 7 divided by 3 squared gives 243, as does 3 to the power of 5. This law states that when raising a power to a power, we multiply the powers together. For example, x to the power of 5 raised to the power of 3, we multiply these two powers together, giving x to the power of 15. Or repeating the calculation numerically, 2 to the power of 5 cubed, we keep the base 2 the same, and we multiply the two powers together, giving 2 to the power of 15. Checking it on the calculator, typing in the first calculation, 2 to the power of 5 raised to the power of 3 and then 2 to the power of 15. Again, giving the same result. The next law states that any number, except 0, raised to the power of 0 is equal to 1. So for example, 5 to the power of 0 is equal to 1, as is 10 to the power of 0. Verifying on the calculator, 10 to the power of 0 is equal to 1. The next law states that when the base is a product of terms, multiplication of terms with a bracket around them, raised to a power, then the power is applied to both terms and the results are then multiplied together. For example, negative 3x is negative 3 multiplying x, and in brackets we have to cube that. So we need to cube the first term, cube the negative 3, and also cube the x, and then multiply the result together, giving the result of negative 27x cubed. Forming the same calculation numerically, negative 3 times 2 in brackets cubed, so we need to cube the negative 3 and cube the 2, giving negative 27 times 8, which is equal to 216. Negative 216. Typing the calculation in, bracket, negative 3 times 2 raised to the power of 3, negative 216. The next law states that when the base is a quotient or a division of terms in a bracket raised to a power, then that power must be applied to both terms, the numerator and the denominator, and then the terms must be divided. For example, 3x divided by 2 in brackets has to be squared. So we need to square the numerator and also square the denominator and then divide the results. For squaring the numerator, we need to square the 3 and square the x, giving 9x squared. And in the denominator, squaring the 2 gives 4. So the result is 9x squared over 4. Performing the same calculation numerically, we need to square the numerator, so we need to square the product of 3 times 4, so we need to square the 3 and square the 4, giving 9 and 16, and in the denominator we need to square the 2, giving 4, giving an overall result of 36, which again we can check on the calculator. Brackets, fraction, 3 times 4 over 2, close the brackets, raise the power of 2, equals 36. The next law states that when the base a is raised to a negative integer, a negative whole number, it's equal to the reciprocal of the base, or 1 over the base, raised to a positive integer, positive power. So for example, x to the power of negative 3 is equal to 1 over x to the power of positive 3. That's 1 over x cubed. And numerically, 2 to the power of negative 4 is equal to 1 over 2 to the power of positive 4. And that's equal to 1/16. Verifying that one, 2 with the power of negative 4 is equal to 0.0625, and of course if I put in 1/16, we also get the same result. These final two laws state that when the base a is raised to the power of 1, it's simply written as a. And when the base a is raised to the power of negative 1, it's equal to the reciprocal of a, or equal to 1 over a. So for example, 10 to the negative 1 is equal to 1 over 10, a tenth, and 5 to the negative 1 is equal to 1 over 5, or a fifth. Verifying one of those on the calculator, 10 to the power of negative 1 equal to 0.1. In this question, we're asked to write the expression as a fraction. Now, since there are no brackets here, the power only applies to the term it's next to. It only applies to the x. If we first start by writing the expression with the multiplication visible, and then applying the law of indices for a negative power, rewriting x to the power of negative 3 as 1 over x cubed. Then if we write 4 as a fraction and multiply the fractions together, we'll get the required result of 4 over x cubed. In this final question, we're asked to express the product there in the form 3 to the power of k, where k is an integer, a whole number, to be determined. Now, since we're asked to express it in the form 3 to a power, we should start by writing 9 as 3 squared. And then if we apply the power to a power rule, multiplying those two powers together, giving 3 to the power of 10. Then if we add the powers, giving 3 to the power of 14 in the form required. So k is equal to 14.